Hello grade 9 students. Our topic for today is all about on how to determine the nature of the roots of the quadratic equations and on how to find the sum and product of its roots. Okay, but before we proceed to our main topic for today, we are going to review first on how to solve a quadratic equation using the quadratic formula. Okay, recall that a quadratic equation has its standard form ax squared plus bx plus c equals 0, wherein a, b, and c are arbitrary constant and a must not be equal to 0. And the quadratic formula is given as x is equal to negative b plus minus the square root of b squared minus 4ac all over 2a. And the formula in finding the sum of the roots is r sub 1 plus r sub 2 equals negative b over a, and the product of the roots has the formula r sub 1 times r sub 2 equals c over a. Okay? So now, let's solve the given quadratic equation using the quadratic formula. So be reminded that before using the quadratic formula, you are going to see to it that the given quadratic equation must be written in its standard form. Okay, once you have investigated or you have checked that the given quadratic equation is already written in its standard form, that's the only time that you can use the quadratic formula. Okay, now the given quadratic equation x squared plus 3x minus 4 equals 0 is already written in its standard form, so therefore we can now use the quadratic formula. So the quadratic formula is in the form x is equal to negative b plus minus the square root of b squared minus 4ac all over 2a. So x is equal to negative b is 3 plus minus the square root of b is 3 quantity squared minus 4 times a is 1 and c is negative 4 all over 2 times a is 1. So you will now have x is equal to negative 3 plus minus the square of 3 is 9. So negative 4 times 1 is negative 4 times negative 4 is positive 16. All over 2 times 1 is 2. So you will now have x is equal to negative 3 plus minus the square root of 9 plus 16 is 25 over 2. So you have x is equal to negative 3 plus minus the square root of 25 is 5 over 2. Now, you are going to separate the plus and minus sign of positive. So you will now have x sub 1 is equal to negative 3 plus 5 over 2. So x sub 1 is equal to negative 3 plus positive 5 is positive 2 over 2. Therefore, x sub 1 equals positive 1. The other one, x sub 2 is equal to negative 3 minus 5 over 2. So x sub 2 is equal to negative 3 plus negative 5 is negative 8 over 2. Therefore, x sub 2 is equal to negative 8 divided by 2 is negative 4. So, x sub 1 is 1, x sub 2 is negative 4. So, another example. So, if we have x squared minus x minus 3 equals 0. Now, as you can see, the given quadratic equation is already in its standard form. So, we can right away use the quadratic formula. So, writing the quadratic formula, x is equal to negative b plus minus the square root of b squared minus 4ac all over 2a. So, x is equal to negative, b is negative 1, plus minus the square root of b is negative 1, quantity squared, minus 4 times a is 2, times c is negative 3, over 2 times a is 2. So, you will now have x is equal to negative times negative 1 is positive 1 plus minus the square root of negative 1 squared is positive 1. Negative 4 times 1 is negative 4. And negative 4 times 2 is negative 8 times negative 3 is positive 24 over 2 times 2 is 4. So, you will now have x is equal to 1 plus minus the square root of 1 plus 24 is 25 over 4. So, you will now have x is equal to 1 plus minus the square root of 25 is 5 over 4. Separate the plus and minus sign of 5. You will have x sub 1 is equal to 1 plus 5 over 4 is equal to 6 over 4 is equal to 6 and 4 has a common factor which is 2. So, dividing both sides of both numbers by 2, so you have 6 divided by 2 is 3 and 4 divided by 2 is 2. So, x sub 1 is 3 over 2. So, x sub 2 is equal to 1 minus 5 over 4. So, x sub 2 is equal to 1 plus negative 5 is negative 4 over 4 is equal. So, negative 4 divided by 4 is negative 1. So, therefore, x sub 2 is negative 1. Okay? So, that is on how to solve a quadratic equation using the quadratic formula. Now, after solving a quadratic equation using the quadratic formula, we are now going to determine the nature of the roots of the quadratic equation. Okay? From the quadratic formula, x squared, from the quadratic formula, x is equal to negative b plus minus the square root of b squared minus 4ac minus 4ac all over 2a. The radicand, this radicand, b squared minus 4ac is what we called the discriminant. Discriminant. Okay, it is the discriminant that determines or characterizes that determines that or characterizes the nature of the roots of the quadratic equation. Okay, so this is the discriminant, and this is the nature of the roots. Okay, if the discriminant b squared minus 4ac is equal to 0, the nature of the roots of the quadratic equations are real, rational, and equal. If the discriminant b squared minus 4ac is greater than 0 and a perfect square, then the roots are real, rational, and unequal. Now, if the discriminant b squared minus 4ac is greater than 0 but not a perfect square, the roots are real, irrational, and unequal. And if the discriminant b squared minus 4ac is less than 0, the nature of the roots of the quadratic equations are not real and unequal. Okay, so let's review. If the discriminant b squared minus 4ac is equal to 0, the nature of the roots of the quadratic equations are real, rational, and equal. If the discriminant b squared minus 4ac is greater than 0 and a perfect square, then when we say greater than 0 and perfect square, so when we say greater than 0, the numbers are positive, and a perfect square example is 1, 4, 9, 16. You can get the square root. So if the discriminant is greater than 0 and a perfect square, the roots are real, rational, and unequal. If the discriminant b squared minus 4ac is greater than 0 but not a perfect square, when we say greater than 0, positive number, not perfect square, are 2, 3, 5, 6, 7, 8, 10, 11, and so on. So their roots are real, irrational, and unequal. If the discriminant b squared minus 4ac is less than 0, when we say less than 0, the numbers are negative. So those numbers, the roots are not real and unequal. Okay, let's apply or let's find example using the example. Okay. Okay, we were given an equation x times the quantity x minus 3 equals 4. So, before you can use the discriminant to determine the nature of the roots of the quadratic equation, you are going to see to it that the given quadratic equation is in its standard form. So in quadratic form, since the given equation is not written in its quadratic form and in its standard form, so we are going to transform and rewrite it. So you are going to multiply x times x, you will have x squared. x times negative 3, you will have negative 3x. Transpose 4 to the other side, it becomes negative 4 equals 0. Okay, now you can now use the discriminant b squared minus 4ac equals. So b is negative 3 quantity squared minus 4, a is 1, and c is negative 4. So is equal to square of negative 3 is positive 9. Negative 4 times 1 is negative 4 times negative 4 is positive 16 is equal to 9 plus 16 is 25. Now 25 is greater than 0 and a perfect square. So therefore, the roots are real, rational, and unequal. Okay, by checking, we are going to find or the roots to check if the discriminant, to check if the roots are really real, rational, and unequal using the discriminant. So from this equation, x squared minus 3x minus 4 is factorable. So therefore, the factors of x squared minus 3x minus 4 are x minus 4 times x plus 1 equals 0. So that if you are going to multiply negative 4 times x is negative 4x, x times 1 is x. If you are going to add, you will have negative 3x, which is the middle term. Okay? Okay, equating the factors to 0, so you will have x minus 4 equals 0, and the other one, x plus 1 equals 0. So transpose 4 to the other side, you will have x equals 4, and the other one, transposing 1 to the other side, you will have x equals negative 1. So we are going to check. 4 and negative 1 are real numbers, so check. 4 and negative 1 are rational numbers, check. And 4 is not equal to negative 1, so check. So therefore, the description of the discriminant that the roots are real, rational, and unequal are correct. Okay? Next, another example. Okay, we were given the equation, quadratic equation 9x squared plus 12x plus 4 equals 0. Since the given quadratic equation is already in its standard form, so we can use the discriminant. So discriminant b squared minus 4ac c is equal to b is 12 quantity squared minus 4, a is 9 times 4 is equal to 12 squared is 144 minus negative 4 times 9 is negative 36 times 4 is negative 144. So is equal to negative 144 plus negative 144 is 0. So therefore, the roots are real, rational, and equal. Okay, we are going to check. So using this equation, 9x squared plus 12x plus 4 is a perfect square trinomial. Now, if you have a perfect square trinomial as a product, the factors are the square of a binomial. So you are just going to get the square root of the first term, the square root of the last term, and then square. So the square root of 9 squared is 3x plus the square root of 4 is 2. Then square equate is to 0. Okay, equate the factors to 0, you will have 3x plus 2 equals 0. So you will have 3x equals negative 2. Then dividing both sides of the equation by 3, you will have x equals negative 2 over 3. Therefore, x sub 1 is equal to negative 2 over 3 and x sub 2 is equal to negative 2 over 3. So we are going to check by using the discriminant. Negative 2 over 3 and negative 2 over 3 are real numbers, yes. Negative 2 over 3 and negative 2 over 3 are rational numbers. Check. Negative 2 over 3 is equal to negative 2 over 3. Yes, check. So therefore, the description of the roots of the quadratic equation using the discriminants are correct. Okay. Next, example number 3. Okay, we have x squared plus 2x equals negative 1. As you can see, the given quadratic equation is not yet written in its standard form. So therefore, we are going to write it in its standard form. So the standard form must be x squared plus 2x plus 1 equals 0. Now, the quadratic equation is already written in its standard form, so we can now use the discriminant. To the discriminant, b squared minus 4ac equals, b is 2 quantity squared minus 4, a is 1, and c is 1 is equal. Square of 2 is 4. Negative 4 times 1 is negative 4 times 1 is negative 4. So is equal to 4 plus negative 4 is 0. Therefore, the roots are real, rational, and equal. Okay, we are going to check using the roots. Okay, from using the quadratic equation in its standard form. So as you can see, the equation is the perfect square trinomial. So therefore, as I said a while ago, that if the product is a perfect square trinomial, the factors are the square of a binomial. So square root of x squared, you will have x plus the square root of 1 is 1, quantity squared equals 0. Equate the factors to 0, you will have x plus 1 equals 0. Solving for x, you will have x equals negative 1. Therefore, x sub 1 equals negative 1 and x sub 2 equals negative 1. So we are going to check using the discriminant. Negative 1 and negative 1 are real numbers. Yes. Negative 1 and negative 1 are rational numbers. Yes. Negative 1 is equal to negative 1. Yes, they are equal. Okay. Next, number 4. Okay, we were given the equation x squared minus x equals 6. As you can see, the quadratic equation is not yet written in its standard form, so therefore we are going to rewrite or transform it into its standard form. So the standard form becomes x squared minus x, transpose 6 to the other side, it becomes negative 6 equals 0. Now you can now use the discriminant b squared minus 4ac equals. So b is negative 1 quantity squared minus 4 times a is 1 times c is negative 6 is equal to square of negative 1 is positive 1. Negative 4 times 1 is negative 4 times negative 6 is positive 24 is equal to 1 plus 24 is 25. Now 25 is greater than 0 and a perfect square. You can get the square root of 25, which is 5. So therefore, the nature of the roots are real, rational, and unequal. Okay, we are going to check using the roots, finding the roots. So we are going to use the equation in its standard form. So it can be factored out. So the factors are x minus 3 times x plus 2 must be equal to 0. So we are going to check. Negative 3 times x, you will have negative 3x. X plus times 2 is 2x. If you are going to add, you will have negative x, which is the middle term. So our factors are correct. Okay, so equate the factors to 0. You will have x minus 3 equals 0. Transpose 3 to the other side, or solving for x, you will have x equals 3. Now the other one, equate it to 0. You will have x plus 2 equals 0. Transpose 2 to the other side, or solving for x, you will have x equals negative 2. Okay, we are going to check. 3 and negative 2 are real numbers. Yes, check. 3 and negative 2 are rational numbers. Yes, check. 3 is not equal to negative 2. Yes, check. So therefore, the descriptions of the roots of the quadratic equation using the discriminant are correct. Okay? Okay. Now, we are going to determine or to find the sum and product of the roots of the quadratic equations. Now, in this topic, we are going to solve for the value of x using the factorization or using factoring, using the quadratic formula, or any types which is most easier for you to find the value of x, and we are only going to use the formula in checking, okay, so that we would know that our answers are correct. Okay, so 2x squared minus 7x plus 5 equals 0. So it is this is factorable. Okay, the factors of 2x squared is 2x times x. And the factors of 5 is 5 times 1. Since the middle term is negative and the last term is positive, therefore, the sign of all the factors of 5 must all be negative. So that if you are going to multiply negative 5 times x is negative 5x. 2x times negative 1 is negative 2x. If you are going to add, you will have negative 7x, which is the middle term. Okay? Okay. Equating equating the factors to 0, you will have 2x minus 5 equals 0. Then transpose 5 to the other side, the equation becomes 2x equals 5. 5. Then dividing both sides, the application by 2, you will have x is equal to 5 over 2. On the other side, you will have x minus 1 equals 0. Transpose negative 1 to the other side, or solving for x, you will have x is equal to 1. Okay? If you are going to add 5 over 2 plus 1 is equal to, LCD is 2. 2 divided by 2 is 1 times 5 is 10. 2 divided by 2 is 1 times 5 is 5, sorry. Plus 2 divided by 1. 1 has no denominator. It is understood that its denominator is 1. So 2 divided by 1 is 2 times 1 is 2. So you will have 5 plus 2 is 7 over 2. Now, if you are going to multiply 5 over 2 times 1, you will have 5 over 2. Okay, we are going to check using the formula. Okay? In adding roots, the formula is r sub 1 plus r sub 2 equals negative b over a is equal to negative. B is equal to negative 7 and a is equal to 2. So, r sub 1 plus r sub 2 is negative times negative 7 is positive 7 over 2. So, you have the same answer. So, check. Then, r sub 1 times r sub 2 must be equal to c over a is equal to c is 5 and a is 2. So you have the same answer. So this is check. Okay, next. Number 2. Okay, so number 2, you have the quadratic equation is x squared minus 5x plus 6 equals 0. So we are going to, this is the product is factorable. So we have to factor this out. X squared has the factor of x times x, and 6 has the factor of 3 times 2. And since the middle term is negative and the last term is positive, it means that all the factors of 6 are negative. So that if you are going to multiply, negative 3 times x is negative 3x. X times negative 2 is negative 2x. If you are going to add, you will have negative 5x, which is the middle term. Okay? Okay, equating the factors to 0, you will have x minus 3 equals 0. Transpose negative 3 to the other side, or solving for x, you will have x equals 3. Okay, the other side, equate it to 0, you have x minus 2 equals 0. Transposing negative 2 to the other side, or solving for x, you will have x equals 2. Now, if you are going to add 3 plus 2 equals 5. If you are going to multiply 3 times 2 equals 6. So, using the formula, so r sub 1 plus r sub 2 is equal to negative b over a, which is equal to negative b is negative 5 and a is 1. So b negative times negative 5 is positive 5 over 1 is equal to 5 divided by 1 is 5. So you have the same answer. So check. So the product using the finding the product using the formula, r sub 1 times r sub 2 is equal to c over a, which is equal to c is 6 and a is 1. So 6 divided by 1 is 6. So you have the same. So that is check. Okay. Next, another example, number 3. Now, x squared minus 4 is equal to 0. So, if you will notice, the given quadratic equation is the difference of two squares. Now, if you have the product, which is the difference of two squares, the factors must be equal to the sum and difference of two numbers. So, therefore, getting the square root of x squared, you have x. Getting the square root of 4, you have 2. So, one is positive, the other one is negative. Equating the factors to 0, you will have x plus 2 is equal to 0. Then x equals negative 2. The other one, x minus 2 is equal to 0. X equals 2. If you are going to add negative 2 plus 2 equals 0. If you are going to multiply negative 2 times 2, you will have negative 4. So you have negative 4. Okay, if you are going to use the formula, r sub 1 plus r sub 2 is equal to negative b over a, which is equal to negative b is 0 since it is absent, over a is 1. So 0 divided by 1 is 0. So you have the same. So this is check. Then r sub 1 times r sub 2 is equal to c over a, which is equal to c is negative 4 and a is 1, is equal to negative 4 divided by 1 is negative 4. So you have the same answer. So this is check. Another example. So we have 3x squared plus 4x minus 7 equal 0. So as you can see, the given quadratic equation is a general quadratic equation. So this is done by trial and error if you are going to use by factoring. But it would be easier for you if you are going to use the quadratic formula if you are not so familiar in factoring. But since I am familiar in factoring, so I'm going to use the equation. I will solve the equation using factoring. So this can be factored out. Okay, the factors of 3x squared is 3x times x, and the factors of 7 is 7 times 1. And since the middle term is positive and the last term of the quadratic equation is negative, therefore, the factors of the greater factors of 7 must be positive and the lower factor must be negative. So that if you are going to multiply 7 times x, you will have 7x. 3x times negative 1, you will have negative 3x. If you are going to add, you will have positive 4x, the middle term. Okay? So equating the factors to 0, you will have 3x plus 7 equals 0. So 3x equals, transpose 7 to the other side, becomes negative 7. Dividing both sides of the equation by 3, you will now have x is equal to negative 7 over 3. The other one, equate the factors 0. You have x minus 1 equals 0. Transposing 1 to the other side or solving for x, you will have x equals positive 1. Now, if you are going to add negative 7 over 3 plus 1 equals, the LCD is 3. So 3 divided by 3 is 1 times negative 7 is negative 7 plus 3 divided by 1 is 3 times 1 is 3. So you will now have negative 7 plus positive 3 is negative 4 over 3. If you are going to multiply negative 7 over 3 times 1, you will have negative 7 over 3. So if you are going to use the formula, so r sub 1 plus r sub 2 is equal to negative b over a, which is equal to negative b is equal to 4 and 3 and a is equal to 3. Therefore, you have negative 4 over 3. So they are the same. So check. So if you are going to use the formula in finding the product of the roots, so you have r sub 1 times r sub 2 is equal to c over a is equal to c is negative 7 over a is 3. So therefore, you will have negative 7 over 3. So you have negative 7 over 3. Okay, last example. Now, we have 3x squared plus 6x equals 2x minus 1. So as you can see, the given equation is not written in its standard form. So therefore, you are going to collect like terms in this case. So you will have 3x squared. Now, positive 6x plus negative 2x, you will have positive 4x. Negative 1 transposing it to the other side, it becomes positive 1 equals 0. Now, by factoring, this can be factored out. The factor of 3x squared is 3x times x. The factor of 1 is 1 times 1. Since all the terms in the quadratic equation are positive. Therefore, the sign of all the factors of 1 are also positive. So that if you are going to multiply, 1 times x is x, 3x times 1 is 3x. If you are going to add, you will have 4x, the middle term. Okay? Now, equating the factors to 0, you will have 3x plus 1 equal 0. Transpose 1 to the other side, you will have 3x equals negative 1. Dividing both sides of the equation by 3, x now is equal to negative 1/3. Now, on the other side, equate this to 0, you will have x plus 1 equals 0. Transpose 1 to the other side, or solving for x, you will have x equals negative 1. So if you are going to add negative 1/3 plus negative 1, you will have the LCD is 3. So the LCD is 3. Then 3 divided by 3 is 1 times negative 1 is negative 1. 3 divided by 1 is 3 times negative 1 is negative 3. So you will now have negative 1 plus negative 3 is negative 4/3. If you are going to multiply negative 1/3 times negative 1, you will have negative 1 times negative 1 is positive 1/3. So if you are going to solve it using the formula, so r sub 1 plus r sub 2 is equal to negative b/a, which is equal to negative b is 6 over a is 3. Sorry. Negative b is 4 and a is 3. We are going to use this equation. So therefore, it is the sum is negative 4/3. So you have the same. So this is check. The other one, r sub 1 times r sub 2 equals c/a, which is equal to c is 1 and a is 3. So that is 1/3 and this is 1/3. So they are equal. So that is check. Okay, so that is all for today. So please answer the following activity. Activity 1, 1 to 5, you are going to determine the nature of the roots of the following quadratic equation. And for activity 2, you are going to use activity 1 in finding the sum and product of the roots of the given quadratic equation. Okay, thank you very much. And before we depart, I would just like to share a quote from Steve Maraboli, quoted as, "A kind gesture can reach a wound that only compassion can heal." So again, thank you very much and God bless us all.